Hey, what's up guys, my name is Cherno and welcome to the 8th episode in the Serialization series. So it's been a while since the last one, but I thought that, you know what, let's wrap this series up. So over the next week or so, hopefully we'll be done with this. Last time I briefly mentioned something about the fact that we should move on to types, right? And being able to essentially know what type we're about to read. So the way that this currently works, and that you could probably guess that from reading this code, right? We have the ability to read, and we know which read method we should use, right? Such as read int, read long, read float, read double, read bool. We don't have string either. I mean, we can encode strings, of course, as char arrays, which I don't think, can we even do that? Yeah, well, I mean, we could always just convert it into a byte array and then write it along with the size. Strings is another thing we should do though. Anyway, all that aside, what I was getting at was we have the ability to read certain types, but if we're just looking at a stream of bytes that is inside a file, we need something that tells us what type this currently is. Okay, I kind of look at the serialization series from, and in general serialization and what we're implementing here as like almost like a three-step process, right? The first kind of low-level step, I guess, is the actual data, right? Those are the bytes that we want to read into RAM, into memory, when we launch our application, for example. Step two, so that's kind of the actual like data bytes. Then we have the kind of descriptors, right? They tell us what type the data actually is so that we can read the right amount of bytes and interpret them into a type correctly. And the descriptor will also have like a name or something that tells us what data we're actually storing. Like, for example, is this supposed to be the X position of the player on the map? Right? Or is this supposed to be the player's name? Is this supposed to be the width and height of the window? And then one more step backwards is kind of the high-level overview of the actual structure of the serialization database. And that would mean things like, is it organized into objects? Like how are all of these descriptors along with their data, how are all of them arranged, right? How many objects are there? How many fields does each object have, right? And if you go back and watch some of the earlier videos, of course, they did cover a lot about, like I drew diagrams and I actually kind of showed you guys what the format was going to look like. And I think I actually have to go back and watch them because it's been so long and I just don't think I remember exactly what I said. But we're going to kind of just go along with this and hopefully it'll match up. But anyway, that kind of covered all the kind of high-level overview with fields and objects and arrays and all of that stuff. Okay, cool. So let's talk about the types today. How do we write a type? So what I like doing, and this is actually a little bit difficult to do in Java. It's actually surprisingly, well, somewhat surprisingly, a lot easier to get this done in C++ because C++ is a low-level language, which is perfect for this kind of stuff. So is C, by the way. In Java, it's a bit of a drag, but usually what I would do is I would declare some kind of struct, right? And when you declare a struct in something like C, you can actually just look up all the data that's in the struct in memory, and then you can just kind of grab it all like immediately, and it's already available to you as a byte array because that's how it's stored in memory, and you have that kind of direct access to memory, which you don't in Java. So that's why this is going to be probably a bit annoying, but let's start off with actually creating, we're going to get some stuff done today, I promise you. Let's just start off with creating a class that is probably going to be something like a field. So I'll be real simple with my naming. I'm going to call this field. Okay. So this class is actually, pretend that this is the actual representation. Like if you were to print out a stream of bytes, which would make up this class, that's what we will see in our actual data in our file, okay, that gets serialized. Now, one thing I should mention is obviously serialization can be applied to more than just like files, right? It's also used for stuff like network streams. And in fact, the reason we're doing this is so the game programming does have that multiplayer component. So I'm just going to take files as an example so that I don't have to say, you know, streams all the time or something like that. But just obviously when I say that this is what's going to happen, this is what it's going to look like in our file, I mean that's what it's actually going to look like in that serialization stream. Okay, so everything is going to be public. That's the first step. Everything is going to be public because there's no reason to write getters and setters for absolutely everything. This is transparent data that we're simply putting into a class for the purposes of keeping it together, okay? If we could avoid making classes, that actually could be an option as well. That probably wouldn't be a very fun option, but you know, we have to make classes. This is Java. So we'll do something like, we have our data, right? So that's a byte array. That's our actual data for the field. We have to have a type which describes the data. This will probably be a single byte. I'll call this type or data type. We also need to make sure that we have like a string. I might play around with the ordering of these things, but we have to have a string, which we could probably convert into a byte array straight away. So this would be like name, and then we need to have a short probably, which is name length. I imagine this could be a byte. I mean, I doubt names are going to be more than 250 characters, yeah, we'll keep it a short just for fun. So this is kind of like, this is basically all you need to describe a field. Now this is a primitive field, so this isn't something like, let me just make sure that we're on the same page here, that I haven't done any of this. No. Okay, cool. This seems to be all that I have. Anyway, sorry, it's been so long, I just don't know where I am. So we've been over strings and how to store them, right? Usually you store a name, usually you store some kind of length first and then the actual string. There are a few reasons as to why there are a few reasons as to why I don't like storing a termination character at the end. Some people, like, both is totally fine if you want to do both. If you just want to do the termination character without an actual length, I find that problematic just because it means that you have to actually iterate through all the bytes to find out where the string ends. You can't just grab, you don't know how many bytes you need to read, right? Which also means that if it's a very, very long string that, might be, I don't know, a couple kilobytes or something that you don't actually want to read, you can't make that decision until you've gone through all of it and checked every single byte to see if it's a null termination character or if it's 0. So I'm not a fan of that. I mean, no one is really. Having a termination character at the end isn't the worst idea because it means that you can just read in that data immediately into memory, and that's that. You don't have to add a termination character in later. So that's fine, but I guess I save a byte of data every time, a byte of storage. Anyway, that's again details. So what we'll do is, I guess the first thing, when we encounter a field, we should probably know that it is a field. So I'll have something like a byte that says, I don't know what to call this. This will basically be a data storage type, right? So for example, it could be a field, it could be an array, it could be an object. So fields, of course, are things that you find inside objects, and arrays are also things that you find inside objects. And arrays are usually made up of fields, as in an array is a field, an array would be this component of a field, right? You still have that like type, then you have that name, and then these things are where you kind of get fancy, right? Instead of like the data type will still be there, instead of this data, you might also in an array literally just have an integer which says element count, right? And then you suddenly know that, hey, I need to divide this data by the amount of element count, right? So if the data type was an int, and then we know that an int is 4 bytes, at least on the system we're working on. In fact, it should be on all systems, right? This is Java. If an int is 4 bytes and we have 8 ints or something like that, right? We know that data, every single 4 bytes of data needs to get put into its own int. It's like it is its own element, yeah. And then of course that will just result in us having 32 bytes of data here, and then they kind of get put into their each one of them gets inserted into an index in an integer array. So that's an example of how we would implement arrays, but we're doing fields right now, so let's stick with that. That's what this really is. So I should probably call this data storage type. And then we have the name length, and then we have the name, then we have the data type, and we have the data. I think I'm pretty happy with that. I will make a set name method here just for convenience. And this will just let us do a few things. First of all, it will mean that we do something like this dot. So we'll copy this into memory first. I'm not sure if we should do that. Hang on. Let me just, if we go name.getBytes, what does that actually do? In a new byte array. Okay, so that should allocate storage for us automatically. And then, so we set the name to that, and then of course the name length can be set to name.length. Okay, and that's done. And we can cast that into a short. If we were really cool as well, I mean, we are pretty cool, so I guess we'll do this. We'll just make sure that name.length is actually less than the max size, or the max value of a short, right? Which should be like 32,000 because it's signed. Okay, this is just us making sure that we're kind of can be stored in a short. I mean, this should never happen. I don't imagine we'll ever have a string that is more than 32,000 characters in an actual data-oriented kind of serialization format, right? This isn't like a Word document, and even if it was, we wouldn't be storing everything in a single array. Anyway, the point is, that's pretty much all we have for a field. Okay, now. The next thing we'll do is probably create one of these. So there are two things we need to define here, the data type and the data storage type. I might actually just call this container type. I think that might be a better name. So we have the container type and we have the data type. We could even just call this type, okay? We need a definition of all of these. So I'm just trying to, where should I put these? Let's see, types maybe? Container type. Yeah, all right, we'll make separate classes for these. I mean, I would probably just make a bunch of classes in one file, but since we know we can't do that either, looks like we're doing this instead. What did I just do? I just made a new project. That's great. That's great. All right, type. So we've got container type and type. So container type will have something like public static byte object equals like 1. We'll probably, usually when I make these, I'll make something like unknown or something, and that's 0. So that can be used as like an error state. Okay, and then we have objects. We might start at the beginning, right? We'll have field. Array will be separate, right? Because these are enclosing types. No, we still have these because they describe the immediate data that follows. Array and object. Okay, and then I'll just kind of align these and set them up as 2 and 3. Okay, pretty simple. They can never be both. Like we can't have something that is both a field and an array. Like an array is a field. So we don't need to make like a bit field or anything out of this. So 0, 1, 2, 3 should be fine. If we go into type, this is where this gets more fun. I also want to have a public static, what should we do? Int, I guess, get size. I mean, this, yeah, it doesn't have to be an int. And then what this will do is basically based on a certain type, it will just return to us what size, how many size, like what the size is in bytes, right? That'll be useful. So we'll do unknown. I guess we'll just start at the bottom, right? We'll say byte, short. Yeah, I guess we'll just char, which is the same as a short, but it's unsigned. Int. This alignment is a bit annoying. What do we have? Long. Is that it? Struggling to think if that's it. I think that's all we have in Java in terms of the integer types. Okay, then we have float and double. Those are our decimal types. And then we have Boolean. Is that it? Boolean double float, long int, char, short byte. I believe that's it in terms of primitive types. String is probably a completely different beast that I want to tackle later on. We'll cover strings separately because they require separate coverage. And then what this will do is it will look at the type. And if the type is, how does this work again? Do we just have to do, oh, sorry, this should be a byte. All right, yeah, okay. Why would you do that? If it's unknown, I guess we can like assert or something. I don't really care. Is this gonna, must be constant expressions. Okay, well, I mean, yeah, I guess that's a good signal for us to actually make them constant expressions, because I did forget to make them final. Same with the container types as well. Okay, so yeah, we'll just assert to make sure that we're in trouble. Bytes. These are gonna be one-line statements. Return 1. Okay, let's make a bunch of these. Short, char, int, long, float, double, and boolean. So booleans, again, I did talk about packing last time. We're not going to worry about that too much, I think. We'll just make them 1 byte. I mean, we do assert, so we can just return -1 or something. Or 0. That'll be bad. Okay, so we can just leave that alone. Okay, so short, 2 to 4, 8, oops, 4, 8, and 1. Okay, so this is just a little conversion chart. I don't know if Java has this actually. I'm kind of used to doing this stuff in C++, which of course doesn't have anything like that. So I wonder if I could probably just do something like integer.size. Yeah, okay. I mean, that's probably better, isn't it? Let's just take a look at what that value actually is. Oh, really? All right. Let's quickly attach source here and take a look at size. 32, so it's in bits. So yeah, it's okay. We know that the sizes are this. We're going to assume that this doesn't change. It might in 10 years, in 20 years, in 100 years, but I'm sure it's fine. Okay, cool. So there we go. We've got a bunch of types now. That's good. We know what size each type is, and then we've got a bunch of container types as well. So now the process is really simple. Every one of these classes that we have field, right? Because we can't simply access this data as a stream of singular data, especially because we do have arrays, which means that these are actually stored in a different location in memory to say these. So I'm assuming Java would probably also store this in a row. So we might have something like container type, and then like literally the next byte. So the offset of a field instance plus 1 byte would be the beginning of name length, plus 3 bytes would be the beginning of this. However, this would be a pointer to a different area of memory because it's an array, right? Especially because it's varying sizes. And you could make this name be 1 byte long, you could make it be 50 bytes long, you could make it be a megabyte. And then we have type, and then we have a pointer to data. So we can't just grab this anyway. So what we do need to do is have a or get bytes. How about that? Now, we don't want to do it this way. This is one of the ways this is what I talked about in the serialization writer. We could return a new byte array every time, which would mean that we allocate memory every time, fill that memory, and then in the end, we would need to copy it into our actual stream anyway. So that's terrible. We want to do it this way, which is where we simply take in a pointer to where we are in the byte thing and then we write it in, right? So we take in this case, the array of bytes and then a pointer to where we are in that array of bytes. And then what value to write. So this is kind of what we want to do. Again, really simple to do. We do need to have a static import to serialization writer. So if I just import static into field, we'll get that. And then all I'm going to do is this will return an int, right? As same again, this is going to look the same. It's going to look the same as what it does here. It returns an int, and it's going to take in these parameters, only these two. Okay, and then what it's going to do is write everything down. So how's it going to do that? Well, glad you asked. So first of all, the first thing it'll write is, of course, destination pointer plus plus. At the end, we can return pointer. Whoops. Big difference in what that does. We will write to be the container type. Then we will write the name length. So again, this is why we need this serialization writer, because this is where it gets fun. Because now we're kind of combining, we're actually writing primitives, not just single bytes, which is what we did over here. We wrote single bytes. So we want to call write bytes, the destination being the destination, the pointer being whatever pointer is, and of course pointer will be assigned back to that. And then the value that we're writing in this case is going to be name length. So we've written name length, and then I guess we can, if we look at write bytes, I believe we wrote one of these for a byte array, didn't we? I hope we did. Did we? Oh, we even wrote one for string. So we do have one for string. That's cool. Oh, yes, we did up here. So this kind of write bytes thing is what we're also going to use. But that's, what was I saying in reference to what? Oh, that's right, because we're writing the name right now. So if we just do name, that's a byte array, then it should do this, and it will, yeah, okay. So that was properly implemented, I was just making sure. Then we'll write the type, so you can see how easy this is, right? We could even, you know what, for consistency's sake, let's also write container type using that. I mean, we might as well. Data, okay, that's it. And then we can just return pointer. That has filled up our destination buffer with all of the data that makes up a field. Okay, you guys could probably kind of see how this whole serialization thing works now. It's going to be a lot more of this, okay? Reading it is going to be an entirely different beast, and we'll obviously cover that. But the writing part of it is a lot easier than reading, especially once you've defined, once you've decided on a concrete kind of implementation. Like once you have a design that you know is good, you're ready to go. So let's test this out, as we always do. We've got the nice ability to print bytes. If I just run this real quick, okay, that'll just print that, I guess. Is that what we expected? Oh, this will just print that. So I just want to see print bytes data. Okay, so that'll just print that. That's a bit annoying, but okay, sure, fine, whatever. Let's get rid of this. So field, field equals new field. Field dot container type. So this is going to be, again, we can create subclasses for this. We don't really need to. In this case, I think I will make a constructor that just takes in a container type. Oh, sorry, I should mention the container type is always going to be type.field, of course, or container type.field, because yeah, it's a field, right? So this is easy. We can make this static final, and you know, if we want it to be really cool, we could bring up the container type to be caps so that we know it's final. However, we also get like set name we can do, I guess, and then obviously stuff like setting integers and stuff because of the actual data that it is. That's going to be a bit difficult. I wonder if there's a better way to do that. You could provide, you know what? I'm just thinking if there's a way to template this or to make this a generic class. There might be. The problem is, can we reliably get... Oh, actually, there should be, shouldn't there? As long as we've got every single possible implementation. Yeah, there probably isn't because it's Java. All right, let's, for example, write out an integer. So I'll create an int field. which extends field. I don't know what I'm doing, by the way. We're just going to see if this works out. Then an int field would just really probably take in an int string name int data value. And then what that could do is get out this thing going. Data. This also means that we have to copy data. Unfortunately, I kind of did want to avoid that. But we'll go for now. So this is why I had the type get size type dot int. Right, bytes. Destination being data, pointer being 0, value being value. And then the name, of course, we have to run set name. And that's it. So this is just kind of almost like a little convenience. You could do something like set int or something like that. But again, since we do need a new field every time, this will probably work out better anyway. So we'll do something like new int field test and 8. Okay. And we'll import that. And then we can print out field get bytes. So we will have our byte array. Data equals new byte. Do we know how big this needs to be? We also don't know how big this needs to be, which is annoying. I mean, do we need to know how big this thing is? We'll just say 100 for now. We'll talk about sizes or something next time. Get bytes data 0. It's going to print bytes, is it? That returns an int apparently. Oh, of course, yeah. So, data. Okay, so let's see what happens here. We probably get a lot, yeah. Okay, so there. That's the end, I believe. That should be the end. So these are the bytes that we got. Let's just pop them here. Let's take a look at what they are. Looking at the structure, we know what they are anyway. But we've got the container type, which is field, of course. That should result in a single byte that is set to 1, field 1. That's the first byte that we have. Then we have the name length, which is a 2-byte short. And that should be the length of test, which should be 4 characters. So those are the 2 bytes that describe that, right? And then we have this stuff which looks a bit weird. That's actually the 4 characters, I assume. TEST. You can see that they do. Okay, I was going to say they match, but they don't because one's lowercase, one's uppercase. But TES, capital T, lowercase e, s, and t. Then we should have the type, which we haven't set, which is why it's set to 0. And then after that, we have the actual data, which should be 4 bytes. And they should result in 8. Okay, there you go. There's our field. One thing I should mention is that we did not set the type, unfortunately. So if we do set the type by just saying type equals type.int, then the only thing we should see is that if this is our current thing without the type, we should see this byte over here be set to like 4 or something, right? Where's type gone? 4. Okay, so let's run it again. And you can see now, if I compare these two, we have the 4, okay, which means it's an integer. Okay, cool. So that wraps up this video. Hopefully you learned something. If you did, please hit the like button on the video. I should mention also that this is pretty much all it takes to write out fields. Next time we might create more of these subclasses. I kind of like that idea. The only thing I'm a little bit skeptical about is this whole byte allocation thing. If we could somehow avoid that, which we can technically, then that would be a lot better. It's just that I'm thinking about whether or not there is an actual optimized way to do that in Java. Because if this was, C++, we would simply store a pointer to the value, which, I mean, the other thing is, in this case, it's actually going to be pretty much indistinguishable whether or not we copy this data, because it is a primitive type, right? 4 bytes is nothing. It's okay to allocate something that's 4 bytes. Like if we had like a reference to it or something, then that would also be 4 bytes on a 32-bit system. So it's fine, right? I think that this is we're going to get away with this. For something like strings that could be several hundred bytes or something long, probably not the best idea. Certainly not for arrays. Probably not objects. But for primitive types, I think copying data and creating actual new allocated memory is fine. All right, anyway, thanks for watching, guys. Hope you enjoyed that video. If you did and you really liked it, you can support me on patreon.com/the Cherno. That'll just help me make more videos, really. And if that's something you're interested in, then you should probably become a patron. All right, guys, thanks for watching. I'll see you next time. Goodbye.